Hi guys, welcome to AllCBTs. My name is Faith. Today we'll be looking at chemical bonding. Sit back and relax. We'll be right back. Welcome back. Chemical bonding. Now, what is chemical bonding? I'm sure you have all heard of chemical bonding. Now, we know that we have so many electrons. We have different electrons. Now, these electrons, they undergo one or two bonding. They undergo bonding. Now, this chemical bonding, what is chemical bonding? Chemical bonding is all about how atoms stick together to form substances. Now, when atoms stick together, they form different substances. For example, we have heard of H2O. We have heard of this our H2O, the water that we drink. Now, it is combination of hydrogen atom and the oxygen atom to form water. So, for different substances that we use from day to day, in fact, even our oxygen goes through chemical bonding. Why? There are two molecules of oxygen or two atoms of oxygen that will combine together to form the one that we breathe in. So this chemical bonding happens every day in our daily life. Without chemical bonding, everybody will cease to exist. So chemical bonding is all about how atoms stick together to form substances. Most atoms don't like to exist alone. They tend to combine with others so they can become more stable. Yes. Now, this stability usually comes from having a full outer electron shell. Now, if you look at most of our elements on their own, for example, let's look at the famous sodium chloride, our table salt, which is NaCl. Now, if you look at NaCl, the NaCl, is combination of sodium and chlorine. Normally, sodium is, positively charged, which means that it will give out one electron, while Cl is Cl minus, which means that it will gain one electron. Don't forget that this one is ready to give out, this one is ready to gain. So when this one now gives this one its electron, it will now be stable and give us NaCl, the stable NaCl, because now when this one already giving this one the electron, it will now attain 2,8. This one to attain its stable 2,8. That is how we can do that. Now, there are three main types of chemical bonding. We have the ionic bond, we have covalent bond, and we have the metallic bond. These are the main bondings that we have. Types of chemical bonding. So this is the theoretical way that our atoms they bond. This is how covalent bonding looks like. This is how ionic bonding will look like. This is how metallic bonding looks like, and this is molecular bonding. Now let's talk about the ionic bonding. Ionic bonding, it happens when only one atom gives away electrons and another atom is accepting. Now let us look at that particular one that we talked about, sodium and chlorine. That's a very good example of ionic bonding. This usually occurs between a metal. Now, emphasis on a metal and a non-metal. That means in this process, it will always require a metal and a non-metal. Don't forget that all metals are electron donors, while non-metals are electron acceptors. So the metal, which is the electron donor, will always give out electron. So if you're going to give out electron to the non-metal, then they will now become stable. Now, sometimes you might not see it as ionic bonding. Sometimes you might see it as electrovalent bonding. You might see it like this sometimes. The atom that loses electrons becomes a positively charged ion. That is the metal. Look at all metals are positively charged. While the atom that gains electron, the electron acceptors, becomes a negatively charged ion. That is a cation. For example, now I said sodium and chlorine. Sodium is Na plus, chlorine is Cl minus. This is a cation because that is positively charged. This is an anion, it's negatively charged. These opposite charges attract each other, forming a strong bond. Now, this electrovalent bonding or ionic bonding is a very, very strong bonding. Is a very, very strong bond. And don't forget that it happens between a metal and a non-metal. That's the difference. That's the major thing that you should note about ionic bonding. Put simply, one atom donates, the other receives, and they stick together because of opposite charges. Don't forget that opposite charges will attract, while unlike charges will attract, while like charges will repel. Don't forget that Na plus and Cl minus, they are unlike charges, so they will attract to give us NaCl. Now, what are the key features of this ionic bonding? Number one, they have high melting and boiling points, conduct electricity when dissolved in water or molten. That means they can act as electrolytes. Why? Because electrolytes conduct electricity in molten states. They often form crystalline solids. These are some key features of ionic compounds. Number two, looking at covalent bonding. Now, covalent bonding is a little bit different from ionic bonding. Why? Because it happens when atoms share electrons. Don't forget that in ionic bonding, we said only one is giving. One will give, one will accept. But this one, they are both going to share. They are both going to share electrons. They will share electrons instead of transferring them. This occurs between non-metals. Now, another difference that we can cite from this is that ionic bonding, it requires a metal and a non-metal, but covalent bonding requires two non-metals. Metals don't have anything to do with covalent bonding. The shared electrons help both atoms to achieve a stable outer shell. These two non-metals, they will share electrons. For example, if you look at this compound, methane, let's look at methane. Methane is CH4. Now, carbon is number 6 on the periodic table, while hydrogen is 1. Now, let's look at something. Let's quickly look at something between this CH4. Now, carbon is 6, that is 2, 4. So it needs 4 more electrons to become stable so that it can attain the stable 2,8. It needs 4 more. Now this H4, H is only 1, right? Now, this H and this C, they are going to share. Now, how does that happen? This is the C now. Okay, let us draw it. Let us draw it. Now, let's say this is our C, and this is our 1, 2, 3, 4. So remains 4. Now this is our hydrogen. We have 4 hydrogens. So one hydrogen will come and share itself, while hydrogen is just 1. Another one too will come and share itself again, 1. Another one will come and share itself again, 1. Another one will not share itself again. At the end of the day, they are all sharing. Now, after this hydrogen has already shared this 4, you will notice that it has now obtained the stable configuration. Why? Because if you count as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8 is now 8. So it is now stable. This is what happens in covalent bonding. Now think of it like a team work. Both atoms are contributing electrons and they benefit from sharing. Types of covalent bonds. We have types of covalent. We have the single bond, that is 1 pair. We have the double bond, that's 2 pairs shared. We have the triple bond, we do it like that, is triple bond shared. Now, what are the key features or what are the characteristics of covalent bonding? Now, these compounds that bond by this covalent bonding, they generally have a low melting and boiling point. They have low melting and boiling points. Now, they do not conduct electricity. Why? Because don't forget that we said this is non-metals that undergo this covalent bonding. So for sure, they cannot conduct electricity. They can form gases, liquids, and soft solids. Why? Because they are non-metals. Let's go to the third bonding, that is metallic bonding. Metallic bonding occurs between metal atoms. Metal releases some of their electrons, forming a sea of electrons that moves freely. The metal ions are held together by attraction of these free moving electrons. Now, this metallic bonding is quite different from other bonding. Now, in this particular bonding, no particular one is sharing, no one is donating, no one is accepting. It's just telling us that it is the bond between metal atoms. These are the bonding these are the free moving bonds. Because now these metals, they release electrons. Now, this is why they can conduct electricity, because they have free electrons. Metals have free electrons. So when they conduct electricity, these electrons can carry this electricity to another part of it. Now, these metal ions are now held together by attraction of these free moving electrons. So the bonding between these free electrons that are on the surface of a metal is what we call the metallic bonding. And most times, metallic bonding is just telling us about the properties of the metal itself. Simple idea. Positive metal ions are surrounded by a cloud of mobile electrons. Now, what are the key features? Good conductors of heat and electricity. Now, when you are looking at metallic bonding, if you want to know these characteristics of metallic bonding, just know that if you know the characteristics and what metals do, the characteristics of metals are the same to the characteristics of this metallic bonding. Now, we can see that metals are good conductors, they are malleable, they are ductile, they are shiny or lustrous. These are properties of metals. So this metallic bonding, they are what gives these characteristics to these metals. It is bonding that makes these metals good conductor, that makes them malleable, which means that they can be hammered into shape, which makes them ductile, which means that they can be drawn into wires, and makes them shiny or lustrous. Now let us quickly compare. Now we have seen that ionic means metal plus non-metal, and it's talking about the transfer of electrons. We have seen that covalent is non-metal plus non-metal, two non-metals, and it has to do with sharing of electrons. We have seen that metallic bonding is talking about metal atoms alone. They are just talking about metals, and we're talking about C of free electrons. So it's like the bond between this C of free electrons. Now, for example, we can say sodium chloride is formed through ionic bonding. Sodium gives one electron to chlorine, forming oppositely charged ions that attract each other strongly, like what we said. Water, H2O, is a covalent compound. Oxygen shares electrons with hydrogen atoms, allowing all atoms to achieve stable electronic configuration. Yes, now because they are two non-metals, so they share electrons. Now your assignment. Number 1, explain the main difference between ionic and covalent bonding. Explain the main difference between ionic and covalent bonding using examples. So using examples, you're going to explain what are ionic bonding and what is covalent bonding. And you can now further, if you did not mention some things, for example, if you did not mention types of covalent bonding or types of ionic bonding, you can now drop it in the comment section. Number 2, why are metals good conductors of electricity based on metallic bonding? Why are they good conductors of electricity based on metallic bonding? So what is the characteristic of this metallic bonding that makes metals to have that good, to make them be good conductors of electricity? So when you are done with this assignment, drop it in the comments section. And if you also have any question, make sure you drop it in the comment section. Come to the end of our class. Have a very nice day. Goodbye, everybody.
Hi, I'm sure you enjoyed the video you just watched. To see more content as that, prepare you for your upcoming exam, make sure to smash the subscribe button and turn on notification. Also, remember that you can use the comment section to send us your questions or your inquiries, and we are happy to take them. I'll see you in the next video. Bye.